On homework 20, we're going to start out by using a trigonometric ratio to find the side length in a right triangle. And we're actually going to use our calculators because we've got the sine, the cosine, and the tangent. So we want to think about our trigonometric ratios for those. The sine, we said, is the opposite over the hypotenuse. The cosine is the adjacent side over the hypotenuse. And the tangent is the opposite over the adjacent. So we want to look at our angle and determine which two of the sides we have so we know which one we want to use. So here we have 20. This is our opposite side. This is our adjacent side. This is our hypotenuse. Since we have the adjacent and the hypotenuse labeled, we want to use the cosine of 20 degrees. So we're going to say that the cosine of 20 is equal to the adjacent, which is x, over the hypotenuse, which is 19. And then we want to solve this for x, so we're just going to go ahead and multiply by the 19. So 19 times the cosine of 20 is equal to x. Now that's in degrees, so your calculator does need to be in degree mode, which if you're using one of these, it probably is. If you're on a Texas Instrument calculator, you want to check your default to make sure it's not in radians, but it's in degrees. And so, all we're going to do is punch it into our calculator. 19 cosine of 20 equals, and I'm getting on my calculator 17.854, ... I want to round my answer to the nearest tenth, so this one I'm going to end up rounding up. And so 17.9 is going to be what the length of this side over here ends up being. So on the second one, if I'm looking for that one, I'm solving x in my right triangle. Again, I have this angle labeled, so this is my opposite, this is my adjacent, this is my hypotenuse. And again, I have the adjacent and the hypotenuse, so I'm going to use the cosine again. So I'm going to say that the cosine of 65 degrees is equal to the adjacent, which is 18, over the hypotenuse, which is x. Now in this one, when I solve it, first of all, I'm multiplying by my x. So I have x cosine of 65 equals 18. And then to get x by itself, I end up having to divide. So x is going to equal 18 divided by the cosine of 65. And so on my calculator, 18 divided by the cosine of 65 gives me 42.591. Rounding to the nearest tenth then, 42.6 would be my answer for how long my hypotenuse would be. So on number 3, again, we're going to solve. I look at that and I say, okay, this is my opposite, my adjacent, and my hypotenuse. This time I have the opposite and the hypotenuse, so I'm going to use the sine. The sine of 51 degrees equals the opposite side, which is x, over the hypotenuse, which is 8. So in order to solve that, I'm multiplying by the 8. So 8 sine of 51 is equal to x. And then, of course, I'm using my calculator again. So 8 times the sine of 51 degrees is 6.217. Rounding to the nearest tenth then, 6.2 is going to be the answer that I want to use. 4, 5, and 6 are using trigonometry to find distances. And in fact, these are going to be just like the previous problems, but now they're putting it into an application problem to see how do I apply what we just learned up there. It says a kite is flying 79 feet off the ground, and its line is pulled taut, which means it's tight. The angle of elevation, so from the ground up, is 57 degrees. Find the length of the line, round your answer to the nearest tenth. So they were nice. They already drew the pictures out for you on Alex, that I have my kite flying up here, my angle of elevation is 57, and that it ends up being 79 degrees off. If I look here, I have my opposite and my hypotenuse, so I'm going to use the sine. The sine of 57 degrees is equal to the opposite side, which is 79, over the hypotenuse, which I don't know, so I'm just going to put an x there. So again, when I solve this one where I have the x in the denominator of my fraction, I'm going to times by the x first. So x sine of 57 equals 79. And then I end up dividing by the sine of 57. So we're going to take 79 divided by the sine of 57 degrees, and we get 94.196. Again, this says round to the nearest tenth, and so 94.2, and this would be in feet, since we were in feet on our measuring our height, and so the length of our line, 94.2 feet. Number 5 says a ladder leans against the side of a house. The angle of elevation of the ladder is 61 degrees. So again, from the ground up is the angle of elevation, so 61 degrees. The top of the ladder is 14 feet above the ground, so they measured up here, it's 14 feet here. Find the distance from the bottom of the ladder to the side of the house. So I'm looking from the bottom of the ladder to the side of the house. I'm looking for this side down here. Again, they were nice, drew out the pictures, you don't even have to draw them. We want to figure out then what x is. So I'm going to have on this one the opposite side and the adjacent side. So opposite over adjacent is tangent. So I would use the tangent of 61 equals the opposite side, which is 14, excuse me. Sometimes you got to look up here because it's hard to read their writing, over the adjacent side, which is the side we were looking for, x. Here's another one where we have the x in the denominator of our fraction. So we times by the x first. So x tangent of 61 equals 14. And then we have to divide by the tangent of 61. 14 divided by the tangent of 61 says 7.76. Again, I'm rounding to the nearest tenth. So 7.8, and we were in feet, so the distance from the bottom of the ladder to the house is 7.8 feet. So number 6 says, a ladder leans against the side of the house. Again, the angle of elevation is 66, so they've got that marked for you. When the bottom of the ladder is 12 foot from the side of the house, find the length of the ladder. So this time we're finding this side right here. So on this one we have the adjacent side and the hypotenuse. And so if we have the adjacent and the hypotenuse, we're going to use the cosine. The cosine of 66 equals the adjacent side, which is 12, over the hypotenuse, which we don't know. Again, they gave us the x in the bottom of the fraction. So we're going to times by the x. X cosine of 66 equals 12 then. And then we divide by the cosine of 66. So 12 divided by the cosine of 66 gives me 29.503, rounding to the nearest tenth. We'd have 29.5, and again we were in feet, and so the length of my ladder is going to be 29.5 feet. Seven, 8, and 9, we're using trigonometric ratios to find an angle measure in a right triangle. So again, sine is opposite over hypotenuse, cosine is the adjacent over the hypotenuse, and tangent is opposite over adjacent. And on these ones, we're going to end up finding the degree measure, and so we're going to have to use the inverse of each of these. Some books, they will do this. Inverse sine Sometimes they call it the arc sine. They mean the same thing. So the inverse tangent or arc tangent are the same thing. If you look at your calculator, above the sine, cosine, and tangent in yellow, you will see this inverse sine, sine to the -1, inverse cosine, and inverse tangent or arc sine, arc cosine, and arc tangent. So if you see this word, means the same thing as using this. So on our calculator, we have to use the shift button and then the sine, cosine, or tangent key to get the inverse. So back to our question. We want to find x. We want to find the angle measure. Round your answer to the nearest tenth of a degree. So if I'm finding x, I'm looking and I'm saying I have the opposite and the adjacent sine. So I'm going to say that the tangent of x equals the opposite over the adjacent. So they're going to tell you that x is equal to the inverse tangent or arc tangent of 28 over 23. Well, on our calculator, we're doing this. The inverse tangent of 28 over 23. Now, on some calculators, you need the parentheses around them. On the Casio, if you're using the fraction button, you don't need the parentheses. But on Texas Instrument calculators, most of the time you do need the parentheses. So it's kind of up to you. You have to check to see which way your calculator works. Best case, if you're not sure, put the parentheses. It doesn't hurt to have them there. On the Casio, you don't really need them. So we are going to do shift tangent to get the inverse tangent or arc tangent of 28 23rds. And on the Casio, you have to use the fraction button. If you use division, then you really do need the parentheses. But if you use the fraction button, you don't have to have it there. On my calculator, I'm ending up with 50.599. We're rounding to the nearest tenth, so we would say 50.6 degrees, going to be my answer. So number 8, same kind of thing. I'm finding the measure of the angle, x. I have the opposite and the adjacent side. So again, I'm going to use tangent. The tangent of x equals the opposite, which is 16, over the adjacent 20, so 16/20. So if I'm going to solve this, I'm doing the inverse tangent, or arc tangent, of 16/20. So again, shift tangent of 16/20, and I get 38.659. So rounding that off, I would say 38.7 degrees. So number 9, looking at that one. This time when I look at it, I'm solving for x. I have the opposite and the hypotenuse. So if we have the opposite and the hypotenuse, we want to use the sine. The sine of x equals the opposite side, which is 15, over the hypotenuse, which is 18. And so if I'm going to solve this for x, I have to do the inverse sine or arc sine of 15/18. Oops, I should probably write that the right way. X is equal to the inverse sine of 15/18. So inverse shift sine of 15/18 gives me 56.442, so 56. What I'm writing? 56.4 degrees, going to be my answer for how big that angle is. 10, 11, and 12, we're using trigonometry to find angles of elevation or depression. So again, we're doing the exact same thing we did on a previous problem, but now we're applying it to a real-life application problem. And so we have a 15-foot ladder leaning against the side of the house. The top of the ladder is 13 feet off the ground. We want to find the angle of elevation, and so again, they've got that all labeled for you. We just have to use our rules here in order to figure out what x is. So we have the opposite side and the hypotenuse. We're going to use the sine. The sine of x is equal to the opposite over the hypotenuse, so 13/15. So if we want to solve it for x, we do the inverse of the sine, or the arc sine, of 13/15. Inverse sine of 13 over 15 gives me 60.073. I have to round that to the nearest tenth again, and so I'm going to say 60.1 degrees when I round that off to the nearest tenth. Number 11 says a ramp 44 feet long rises to a platform. So it's on the ground, they're putting it up to a platform for a ramp. The bottom of the platform is 19 feet from the foot of the ramp. Find x, the angle of elevation of the ramp. So how high is that tilted up? Round your answer to the nearest tenth of a degree. So again, I'm finding the measure of this angle. I know the adjacent side and the hypotenuse. So on this one, we're going to use the cosine. The cosine of x should be equal to the adjacent 19 over the hypotenuse, which is 44. So again, since we want to find x, we have to do the inverse of the cosine to undo that, or the arc cosine of 19 over 44. So shift cosine 19/44, and x is going to be 64.416, which rounds off to 64.4 degrees for our answer for what is the angle of our elevation. So number 12 says find x, the angle of depression. So I'm starting on the top and going down. From the top of the lighthouse, that is 172 feet above water level. So here's the top, I went up 172 feet. Above the water level to the water line of a ship, that is 885 feet offshore. So my ship's way out here, it's 885 feet over to get to where the ship is. Round your answer to the nearest tenth of a degree again. So if I'm looking at this one, I have the opposite side and the adjacent side, so I would have to use tangent of x. Tangent is opposite over adjacent. So I have 172 over 885. Again, if I want to find the angle measure, I'm going to use the arc tangent or inverse tangent. So x is equal to the inverse tangent of 172 over 885. And then I'm going to use my calculator to solve that. And so I get 10.998. I round it to the nearest tenth. 9 rounds up to 10, which I have to carry, so that's going to round off to 11.0. Since it tells me to round to the nearest tenth, I do want to show that tenth spot is a 0, so 11.0 degrees is how they're going to want to see that one. (13, 14, 15), we're solving a right triangle, and they're actually going to have you solve for the missing angle and then the two missing sides. On the missing angle, B, what we need to know is that the entire measure, if I add all three angles in my triangle, it adds up to 180 degrees. All three of them add to 180. But since we're working with a right triangle, the right angle is always going to be 90, so the other two angles are going to add up to 90. So if I'm trying to find the missing one, I'm just going to take 90 minus the one I know. And so if we take 90 minus 48, 42 degrees is going to be the measure of that angle. So finding our angle is not going to be too bad. All we're going to do is take 90 minus the angle we know, and that's going to give us our missing one. Then what we're going to do is use the given angle to find our other two sides. So here, if I'm going to find B, I'm going to have the opposite and the adjacent. And so I'm going to use the tangent. I'm going to say that the tangent of 48 degrees is equal to the opposite over the adjacent, so 19 over B. So these are like those first few problems we did where we were finding the missing side. We need to solve that. So we're going to times by our B, and then we have B tangent of 48 equals 19. So we divided by the tangent of 48 and got the B by itself, right? And so if I use my calculator, 19 divided by the tangent of 48 gives me 17.107. I'm rounding to the nearest tenth, so 17.1. So 42 is our angle, our degrees for B. Angle B, 17.1 is the length of side B. We still need to find side C. So on side C, we have the opposite side labeled and the hypotenuse. So opposite over hypotenuse would be the sine. So the sine of 48 degrees is going to equal the opposite 19 over the hypotenuse C. So again, on this one, I end up having to multiply by the C and then divide by the 48, or sine of 48. So C is going to equal to 19 divided by the sine of 48. If you don't mind if I skip a few steps to save myself some room. Multiply by the C, then divide by the sine of 48. So 19 divided by the sine of 48 gives me 25.56. So rounding to the nearest tenth, 25.6 is going to be my answer for how long side C is. So I'm going to find the angle and then both of my sides, and so a little bit longer problem than we've been doing. So number 14, we're going to solve our right triangle again, round to the nearest tenth if we need to round. First thing we're going to do is find out how big A is by taking 90 minus the angle that we already know, which is the 50.9. So if we take 90 minus our 50.9, 39.1 degrees is going to be how big A is, right? So that one should be easy and quick to do. The other ones, I'm going to use the angle that is already marked. I know that this is my opposite, my adjacent, and my hypotenuse. So if I'm trying to find B, I'm going to use the opposite over the adjacent, so I'm going to use tangent. So the tangent of 50.9 is going to equal B over 28.2. So on this one, to solve for B, we just end up having to multiply by the 28.2 times the tangent of 50.9, and we can find our answer for B then. So 28.2 times the tangent of 50.9 gives me 34.700, and so 34.7 going to be my answer for side B. I also have to find side C. So for side C, we have the adjacent side labeled, and the hypotenuse is what we're trying to find. So adjacent over hypotenuse would be cosine. So I'm going to use the cosine of 50.9 degrees on this one. The adjacent side is 28.2 over the hypotenuse, which is our side C that we're trying to find. So again, on this one, since our variable's in the denominator, we would multiply by the C first, and then we'd end up dividing. And so 28.2 divided by the cosine of 50.9 is going to give us our answer. So 28.2 divided by the cosine of 50.9 gives me 44.71. So 44.7 then would be the length of side C. So 39.1 degrees was angle A, 34.7 was side B, and 44.7 is side C.
Big class.
Uh-huh. So 15, we are solving our right triangle, rounding our answers to the nearest tenth. We first are going to find angle B. So we're going to take 90 minus the 46 that we have up there. 90 minus 46 then gives us 44 degrees for B. There's our first answer. Then finding our side lengths. We have this one labeled. This would be my opposite, this would be my adjacent, this would be my hypotenuse. So I want to find A. I'm going to use the opposite and the hypotenuse. So I'm going to use sine of 46 equals the opposite A over the hypotenuse of 22. And so on this one we just need to multiply by our 22. So 22 times the sine of 46 degrees will give us our answer for A. So 22 sine of 46 gives me 15.825. So 15.8 going to be my answer for how long side A is. Side B, we're going to use our adjacent side and our hypotenuse. So adjacent over hypotenuse would be cosine. The cosine of 46 degrees is equal to the adjacent, which is the B, over the hypotenuse of 22, which again on this one makes it easy. We just need to multiply. So 22 times the cosine of 46 is going to be my answer for B. 22 cosine of 46 gives me 15.282, so rounding to the nearest tenth, 15.3 then is going to be my answer for B. The next problems here have you talking about a reference angle. On a reference angle, you're thinking about always going back to the x-axis. So if my angle is in quadrant 1, my reference angle goes down to the x-axis and would be that angle that looks something like that. If my line ends up or my angle ends up being in quadrant 2, again I go down to the x-axis, so this angle here is going to be my reference angle. If I'm in quadrant 3, my angle is going to go up to the x-axis. So again, my reference angle is always between my line and my x-axis. And then of course, in quadrant 4, same kind of thing. If my angle ends up over here, I'm always going to the x-axis. So my reference angle is that angle in there. So if I want to find the reference angle for 7 pi over 9, first of all, I need to know where 7 pi over 9 is. I'm not that good with radian measure. I need to convert it to degrees so I can figure out where the angle is. And so I'm going to go ahead and say 7 pi over 9 times 180 over pi, right? Pi and 180 are equal to each other. And so if I convert that, the pi's cancel out. 9 goes into here 20 times. And so 7 pi over 9 is the same thing as 140 degrees. So if I think about this, 140 degrees is going to go over here in quadrant 2. From there to there is 140. That means my reference angle would be 40 degrees because to get back down to the line I have to go to 180. I then need to convert this back into radians. So if this is in radians, my answer needs to be in radians. So 40 degrees times pi over 180 to change it back. Here the zeros cancel out. I can divide by 2. So 2, 9. So 2 pi over 9 is going to be what my reference angle is for the angle that is 7 pi over 9. Number 17, we want to find the reference angle for a negative 144 degrees. So negative 144 degrees would end up being over here in quadrant 3. But my reference angle goes here. So I'm trying to figure out how much more do I have to go to get to the 180. So if I just take my 180 minus my 144, that tells me this angle here is 36 degrees in the positive direction. And so 36 degrees is what my reference angle is. If I took the 36 here plus the 144, if I went the right direction, I'd end up being at 180. Find the reference angle for negative 11 pi over 9. Again, I'm not very good with radian measures, so I've got to convert it into degrees for my mind to keep straight what I'm doing. And so that's what I'm going to do. Negative 11 pi over 9 times 180 over pi to convert my radian measures. 9 goes into 180 20 times. So if I take negative 11 times 20, I get negative 220. So negative 220 degrees, again, ends up being over here in quadrant 3. And so I'm thinking about, no, negative 220 doesn't end up being in quadrant 3, because I'm not to 180 yet. Negative 220 ends up being in quadrant 2 if I go far enough, because there's 180. So that's negative 220. So what I'm trying to figure out here is how much space is left down here for this angle down here. If this is 220, negative 220, and here's 180, if I take 220 and subtract 180, that means this angle here is going to be 40. The other thing you can do is figure out if this is negative 220, if you took 360 minus 220, that this angle here ends up being 140. Right? And so, again, we have that 40 degree angle, but since this was in radians, we've got to convert that to radians, which we did up there, but we'll do again. So pi over 180, if I cross off my extra 0, I have 4/18, reduces down to 2/9. So 2 pi over 9 is that reference angle, which was 40 degrees. So my reference angle always goes back to the x-axis. How much space is there between the end of my angle and the x-axis in the positive direction? The last, before I do the last three, the last three then are going to give us those bigger angles where we want to make sure it's between 0 and 360 or 0 and negative 360 so that we can get it on our graph. So if we have negative 580, I'm going to start by adding 360 until I have a number that's either between a negative 360 or a positive 360, depending on if you want to draw your angle. So if I take negative 580 plus 360, I get negative 220. So I can either draw my angle in the negative direction, negative 220 degrees, or if I add another 360, then I get my positive angle, positive 140. Either way, negative 220 or positive 140 should end up in the same spot over there in quadrant 2. So I want my reference angle, which they like to have this one today. What do I have left for this angle in here? Well, that angle in there would have to be 40 degrees. Since we're in degrees, we don't have to convert this one to radians. So 40 degrees is going to be my reference angle. So number 20, they didn't change that one a whole lot. I want to find the reference angle for negative 560 degrees. So again, if I add 360, negative 576 plus 360 gives me negative 216. I could just work with that and say, okay, negative 216 goes this way. Or if I want to add another 360 plus 360, it's going to give me the positive angle, 144. So it means this way I'm going 144. In either case, my line ends up something like that, and I'm finding this angle right in here. If this is at 144 and I need to get down to the line, which is at 180, 180 minus 144 means that this angle in here would have to be 36 degrees, right? If I just stopped at the negative and knew this was 216, I could take 216 minus 180 and I'd end up with that same 36 degrees. And the last one, we want to find the reference angle for negative 16 pi over 5. Again, for me, I'm not good with radians in my head. I have to change them to degrees to figure it out. If you're good with working with pi, you can do that. It works. Look at Alex for the explanation. So negative 16 pi over 5 times 180 over pi to do my conversion. So 180 divided by 5 is 36, and then 36 times negative 16 gives me negative 570. Did I get the exact same angle? I did. Well, whoops, now I wrote 60, negative 576. I was so flustered that they gave me the exact same angle that they gave me up there on the previous problem. Oh well. So once it's in degrees, I can change it so that I have an angle either between 0 and negative 360 or 0 and positive 360. Since it's negative, I'm just going to keep adding 360 till I have what I want. In this case, we already did that and said negative 216. Or, if we kept going, positive 144. So, negative 216 or positive 144 gives us that angle that we already did, and we said it was 36 degrees. If I take 180 minus 144 or 216 minus 180, we get 36 degrees. But we have to convert our 36 degrees into radian measure. So times pi over 180. If I take 180 divided by 36, goes in there evenly 5 times, so pi over 5 is what my reference angle is going to be for negative 16 pi over 5. Again, on Alex, they will have the explanation for using pi for the 180 degrees and adding and subtracting, but in my mind, I just can't seem to keep straight where negative 16 pi over 5 is, so I have to change it to degrees first because I know where it is in degrees.